There are 5 properties of indifference curves that you need to know. The first property of indifference curves that you need to know is that indifference curves are downward sloping. We're going to prove this property by reasoning by contradiction. So let's assume that instead of having downward sloping indifference curves, we'd had an upward sloping indifference curve, such as this one. And we're going to draw a basket of good P1 such that we have 3 concert tickets in that basket of goods and 2 books in the basket of goods. And we're going to compare this basket P1 with basket P2, in which there are 5 concert tickets and 4 books. Obviously, because consumers prefer having more of both goods, basket of good P2 is actually going to be preferred to basket of good P1. So it is quite clear that if an indifference curve were upward sloping, we'd be violating the law that more is necessarily better. Therefore, indifference curves are necessarily downward sloping. When you have several indifference curves, the question is to know which one is going to be preferred over another one. So let's take this example here. We have an indifference curve which is in blue, in which you have basket of good P1, and then an indifference curve that's in orange with a basket of good P2. Which one do you think is going to be preferred by the consumer? Clearly, basket of good P1 is going to be preferred by the consumer because basket of good P1 provides 3 books and 3 concert tickets, whereas basket of good P2 provides also 3 concert tickets, but only 2 books. Once again, thinking in terms of this property that more is better, the consumer is going to prefer having more books given a certain number of concert tickets. All right, so here the indifference curve in blue is going to show a higher level of satisfaction to the consumer compared to the indifference curve in orange. We can also reason the same way here with baskets of good P3 and P4. P3 provides more concert tickets for 1 book compared to P4. It's also 1 book. P4 provides 4 concert tickets. P3 is 6 concert tickets. So obviously the consumer will prefer being on the blue indifference curve compared to the orange indifference curve. So the blue indifference curve provides a higher level of utility to the consumer. So to summarize here, the agent prefers P1 to P2. The agent is indifferent between P2 and P4, and the agent therefore necessarily prefers P1 over P4. It's another way of saying the same thing. This leads us to the property number 2. The further the curve is from the origin, the higher the satisfaction. So when you have many indifference curves, you're going to see an increasing level of satisfaction the further you are from the origin. Property number 3, indifference curves do not cross. Once again, we're going to reason by contradiction. So here we have 2 indifference curves that do cross. One is in blue, the other one is in orange, and they cross at the basket of good P1. So assuming that indifference curves show baskets of goods for which the consumer is indifferent, here we're making the assumption that P1 is, or the consumer is indifferent between P1 and P3, and the consumer is indifferent between P1 and P2. Therefore, we should have that the consumer is indifferent between P2 and P3. This is not true, quite obviously, because for basket of good P3, the consumer would get 3 books for 5 concert tickets, whereas at the basket of good P2, the consumer has only 1 book for 5 concert tickets. Therefore, the basket of good P3 is actually preferred to the basket of good P2. Right? So this reasoning here proves that indifference curves cannot cross. So this is property number 3. Indifference curves do not cross. Property number 4, taste for diversity, is going to be represented by the fact that indifference curves are convex. Just a reminder on convexity. Your curves can take 3 different shapes. They're either convex curves, those are the curves in blue. They're either concave curves, so those are the curves in orange here, or they can be linear curves, in which case, well, your curves are actually straight lines. These are the lines in green on this graph. So here we're going to say that indifference curves are actually convex. Why is this the case, and why does that show taste for diversity? So here on this graph, we have a convex indifference curve. We have two baskets of goods that are represented on this graph, P1 and P2. P1 is a large number of books and only one concert ticket, and P5 is 5 concert tickets and only one book. Let's draw a third basket of goods. This is going to be basket of good P3, for which the consumer would have 3 books and 3 concert tickets. If we draw the indifference curve that goes through this point, P3, well, you see that it's an indifference curve that's further away from the origin. It provides more satisfaction to the consumer. This is the case because the consumer prefers having more of each good, or a diversity of each good, rather than having a lot of only one good and small quantities of the other good. So P3 is a more diverse bundle of good, so therefore P3 is going to be preferred to P1 or to P2, which are two baskets of goods in which there's a lot of one good and only a small quantity of the other good. This leads us to the fifth property, which refers to the slope of the indifference curve. So here we're going to show how the slope of the indifference curve actually refers to some type of a sacrifice that the consumer is willing to make. What does the slope of the indifference curve represent? The slope of the indifference curve is the quantity of good B the agent is ready to give up, or the agent is willing to give up, in order to get an additional unit of good C, staying at a constant level of satisfaction. So we're staying on the same indifference curve. What the slope tells you, it tells you how much of B the consumer is willing to get to, how much of B the consumer is willing to sacrifice or is willing to give up in order to get an extra unit of C. Let's take 2 examples. So basket of good P1, you see that the consumer has a lot of good B and only a small quantity of good C. The slope is pretty steep. The fact that the slope is steep at this point P1 suggests that the consumer is willing to give up a lot of B in order to get an extra unit of C. The reason for that is because at point P1, the consumer has a lot of B and does not have much of C. At point P2, the slope of the indifference curve is getting to be pretty flat. This means that the consumer is not willing to give up a large quantity of B in order to get an extra unit of C. This makes sense because at point P2, the consumer has a lot of C and only a very small quantity of B. This leads us to what is called the marginal rate of substitution. When you calculate the slope of the indifference curve in terms of its absolute value, that's called the marginal rate of substitution. So you see that the slope of the indifference curve it's downward sloping. So the slope is actually negative. So to calculate the marginal rate of substitution, we're going to calculate minus the change in B divided by the change in C along the curve. That makes it a positive number. When I write change in B divided by change in C, what that actually means is how much the consumer is willing to give up in terms of B in order to get an extra unit of C. The fifth property is that the marginal rate of substitution decreases when the quantity of C increases and the quantity of B decreases. Said differently, the more one has of a good, the less one is willing to give up of another good to get an additional unit of the abundant good.